Hey dear subscribers, welcome back to the channel. Today's lecture is very important in terms of exam point of view. We are going to discuss all the conceptual questions which are based on the chapter Light. But this is part 1 of the conceptual series. This is based on reflection. We're also going to see in the later classes refraction. Then we're going to combine both reflection and refraction. And we're going to see some more questions. So without wasting any time, let's get started. Listen the lecture with full concentration. Let's get started. This is your question 1 in the worksheet. The question was an MCQ pattern question. See, you are very well aware that the boards now you're going to have MCQs as well. So MCQ, first MCQ which is there is the angle of reflection in the given figure. So let us see the figure also. This was the figure that I have provided you, right? So in this, what does the figure say? See, if we study the figure, this is a concave mirror first of all though, right? Then there is a light ray. So whenever you have a figure which is related to light, see which type of the device is used, from where the light ray is traveling and how it is reflected or refracted depending upon the device. So we'll see that the light ray is traveling through center of curvature, and we know that whenever it travels through center of curvature, it is going to be reflected back along the same path. So this was the question and there were 4 options given. See, now what is the way or the methodology to crack MCQ? See, one would be you either know the answer the moment you read the question, right? Second, you'll just think a little bit that you'll try and apply concepts and then answer. Third is when you don't know the answer, right? Even if you're trying to read the figure, then also you're not getting the answer. Then what has to be done? See, then we can start from the options given. So what is the methodology that if you don't know the answer, then ruling out methodology always work. Ruling out means कि answer ये तो नहीं हो सकता, ये भी नहीं हो सकता, ये भी नहीं हो सकता, तो ultimately you'll read to one option only, one choice only, right? So sometimes this also work when you don't know the answer. But in this case, if your concepts are very clear, because it's a very fundamental thing, that if the light ray passing through the center of curvature, then it again reflected back along the same path. Why? Because this is the normal to the mirror. So that means if this is the normal, that means angle of incidence, can you see here? Angle of incidence is 0. And since it is reflecting back along the same path, along the normal only, so angle of reflection is also going to be 0. Hence the correct option here would be 0. See there, what is the confusion कि 90 डिग्री तो नहीं है. 90 डिग्री उसने पूछा हमसे angle of reflection. Angle of reflection or angle of incidence is always seen with the normal. That means the angle which the reflected ray is making with the normal. So here the reflected ray is along the normal and hence it is 0. Got that? So the correct option here is 0 degrees, which is D option. This is a very fundamental question and very important question also. Moving on to second question. The second question was, see, reading the question is very important. Second question says that an object is placed at a distance of 0.25 meter, okay, in front of a plane mirror. So there is a plane mirror and there is an object here. Now what is the distance between object and the image? So see, this is the situation, that this is the mirror and the object is standing here. Now let's say this distance between the object is given to us as 0.25 meter. Now usually, you know, what is our tendency to read in mind, that ऐसा पूछा होगा कि what is the distance between the object and the mirror, right? ऐसा करोगे तो आंसर देखो क्या आएगा, object and the mirror के बीच में तो distance दिया ही है. फिर हमें लगता है कि this was तो given, then we will think कि अच्छा image and mirror भी हो सकता है. If you don't read the question, such types of mistake may occur and this is a common mistake. It might sound very silly to you, but this is a common mistake. Okay, so image and मिरर के बीच में हम देखते हैं तो हमें फिर फंडामेंटल याद आता है. then we'll say कि प्लेन मिरर का कैरेक्टरिस्टिक्स कि जितनी दूरी पर ऑब्जेक्ट होता है, same distance image is also found. So in hurry we'll take this answer as 0.25. But can you see what is asked? They are asking the distance between object and the image. That means this is the object, so this is the image. So you're asked this distance. Right? So now again we'll have to apply this fundamental that we know that in a plane mirror, object distance is equals to image distance. So if the object is at 0.25, then the image will also be 0.25 from the mirror we are talking. But we are asked object and image के बीच का distance. So we have to add up both of them. So object distance plus image distance. So 0.25 plus 0.25 gives us 0.5. Right? So the correct option is 0.5. So read the question carefully and don't ever get confused as to what is asked, or don't be in a hurry while solving this type of questions. Moving on. Question number 3. A full-length image of a distant tall building definitely can be seen by using, and these are the 4 options, right? So उसने पूछा हमसे कि full length image, if we have to see of any object, here they have particularly mentioned that it is a distant tall building. So then we can use it. Then there are 4 options. Read the options also. So there are 4 options that we have to think in terms of mirror. Whenever we see the option, we know in which direction we have to think, right? So here we have to think in the direction of the mirrors, that we have to identify one of those mirrors through which we can see the full distant image of the building. So see, can you see here that there was a mirror here, right? And there must be a fort or something at a distance from the mirror, but the entire fort can be seen here, right? That means there exists a mirror which can give us the entire image of the building, right? Now can you see this is little curved outwards, this mirror? It's not a plain mirror, definitely it is curved outwards, right? Now that means if it is a curved mirror, that means it can be either concave or convex. So अब देखो plain तो नहीं हो सकता, so that means C or D तो option eliminate हो जाता है, because in both we have plane. So we are either left with concave or convex. Now we have to think. See, concave में तो it is bulged inwards. Cave from cave you remember it is bulged inwards. पर यहाँ तो ये दिखता है bulged outwards. So bulged outwards is only convex mirror. So answer is going to be convex mirror. But see, now how do we remember, or the another way? Concave mirror forms all the type of the images, same size also, distant, diminished also, then magnified also. अब अगर ये मैग्नीफाइड इमेज बना लेगा, then there must be a chance कि जितना भी ऑब्जेक्ट होगा उससे बड़ा उसका इमेज होगा, must not be occupied in any size of the mirror. ठीक है, अगर मैं एक छोटा सा मिरर लेती हूँ तो उसकी मैग्नीफाइड इमेज उस मिरर में नहीं आएगी, ऐसा हो सकता है. True, but we know that convex mirror always forms diminished image, and that too virtual and erect also, right? So if it is called diminished image, it may always forms on the mirror, and it may nahi, it always forms on the mirror. Therefore answer is convex mirror. Can you see here, this was the ray diagram, that this is a distant object wherever it can be. It can be here, it can be here, 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 anywhere on the principal axis. Now if we start drawing the ray diagram, then see a small image is forming here. So this entire object is visible here, right? And hence the answer is convex mirror. Correct option is B, convex mirror. You got the idea? So now this is very important from the exam point of view. Which mirror do we use from to see the full length image? Convex mirror. Moving on to question number 4. Now we have to answer laws of reflection hold good for which, for what? So there are, let us see the option, because from this we cannot make out what is the question. So laws of reflection hold good for, अभी भी समझ नहीं आता, to see all the options. So again they are talking about mirror. The laws of reflection क्या हम plane mirror में apply करेंगे, or in concave, or in convex, or all type of the mirror irrespective of their shape. So dear students, you can see from this diagram, this is the plane mirror. Angle of incidence is equals to angle of reflection. This is a convex mirror. Again, angle of incidence is equals to angle of reflection. This is a concave mirror. Again, angle of incidence is equals to angle of reflection. That means laws of reflection is holding good for all the 3 types of the mirror. So irrespective of their shape, all the mirrors follows the laws of reflection. Okay. So our answer is D, that all the mirrors will follow laws of reflection. Moving on to question number 5. So question number 5 says that an object of size 2 centimeter. The size of the object is given. So I told you, as soon as you read the question, any information that you get, just write it down. So information here was size of the object is 2 centimeter. So we have written that the size of the object is 2 centimeter. right? Size of the object मतलब height, so denoted by HO, is placed at 25 centimeter. Placed मतलब वो कहाँ पर रखा है, where are we placing it? So that means we're talking about objects, it is object distance. Object distance is represented by U. Then, now this is the catch, that whenever we solve any numericals in light, then we have to substitute the values with the sign convention. So whether it is a mirror, whether it is a lens, in all mirror, in all lenses, the object distance is going to be negative. So this is U is equals to minus 25 centimeter. Okay. Now they're given us that if the magnification is 4, so we've written magnification is 4. So they are giving us it is 4, so we're writing it as positive 4. Because it can be negative 4 also. They're giving us it to be 4. You can write it directly. Magnification is equals to plus 4. Then what is the size of the image? So if we have to find out the size of the image, that means we have to find out the HI. Here we will have to write down that size of the image HI is equals to question mark. Now see, if we have to find a HI and magnification is given, definitely this formula of magnification has to be applied. Now since we need a size of the image, height of the object is given, so we'll directly apply the formula HI by HO, right? So magnification is equals to HI by HO. So I'm substituting the value of magnification, M is equals to 4, right? And HO is 2, that is positive 2, so positive 2. So HI is 8 centimeter. So even without this use of this object distance, we can find the size of the image. So sometimes this will happen that though information is given to you, but if that is not used anywhere in the answer, no need to worry if you're getting the answer. The only thing is you should be very sure that you're using the right concept. Okay, so height of the image here is 8 centimeter. अभी उसने और कुछ नहीं पूछा. That's it. The question ends here. So the answer is that the size of the image is 8. Moving to next question. Question number 6. Question number 6 says that an object is placed at the following distances from a concave mirror of focal length 10 cm. So there are certain distances given, and the focal length is given of a concave mirror to be 10 cm. Let us see what are the distances first. 8 centimeter, we are placing once the object at 8, then we're placing it at 15, then at 20, then at 25. So we have to answer thus which of this object will produce. So अगर आप 8 पे रखते हो, then you 15, then you keep it at 20, then you keep it at 25. So which of the object will produce first a diminished real image? किस case में out of the 4 will you get a diminished real image? A magnified real image. Third part is a magnified virtual image. And the fourth part is the same size as that of the object. So can you see this question is based on the ray diagrams that we have learned, all the 6 cases. So 6 cases must be thoroughly clear with you, because I assure you in the exam you're going to see one question which are based on ray diagram. Either that will be a direct question to draw a ray diagram, or that would be in the form of usage that you have to draw the ray diagram, or that can be in form of this type of question where you have to keep the object so that you get a such type of image. That means you should be very sure कि ये 8 सेंटीमीटर का मतलब क्या, कहाँ है ऑब्जेक्ट, 15 मतलब कहाँ है ऑब्जेक्ट. When I say कहाँ है ऑब्जेक्ट, then I talk about the zones that we have dealt in the ray diagram. That means infinity पे है, beyond C है, C पे है, between C and F, at F, between pole and focus. So first, our first job is to see where is that object. Now how will we see? So for that we are given one thing, the focal length. So that is going to be our reference point. If the focal length of the concave mirror is 10 centimeter and you are keeping your object at 8, that means you are keeping the object before focus, nearer to the mirror, right? So can I say, first just analyze this thing. So that means at 8 centimeter the object is between pole and focus, correct? Similarly we'll see 15 centimeter. So that means it would be after focal length, right? So that is going to be between F and C. Why between F and C? Because C means center of curvature, which is twice the focal length, correct? So center of curvature is twice the focal length. That means center of curvature is going to be 20. So F 10 है, C 20 है. So that means we are keeping it between F and C. Now 20 पे क्या है, 20 मतलब at C, because C center of curvature, that means radius of curvature हम देखेंगे. So radius of curvature is twice f. F था 10, so twice f मतलब 20. So here the object is at C. Then the fourth case is the object is beyond C, because C is 20, so it is beyond C. Now this is one way to do the question. Let us first complete this, then we will do the other way also. We'll see the other way also. So now we have all the four this thing are references as to where the object is in terms of the zones of the mirror, right? So now it is very easy for us to recognize. Now we have learned the cases. We know when is the diminished real image form, when is the magnified real image form. See, real image and that too diminished. तो इमेज छोटा कब दिखेगा, जब ऑब्जेक्ट बहुत दूर होगा फ्रॉम द मिरर, राइट? अब बहुत दूर इसमें से कौन सा केस है, बियॉन्ड सी. सो दैट मीन्स आवर आंसर इज गोइंग टू बी व्हेन द ऑब्जेक्ट इज बियॉन्ड सी, राइट? नाउ मैग्नीफाइड रियल इमेज. सो मैग्नीफाइड रियल इमेज मैग्नीफाइड है, अब मैग्नीफाइड है दैट मीन्स द ऑब्जेक्ट मस्ट बी लिटिल क्लोजर, राइट? अभी क्लोज आ गया, सो वो कहाँ होगा, एफ एंड सी के बीच. Why between F and C, मैम, and why not at C? Because C पे तो हमें पता है कि when the object is at C, इमेज भी C पे होता है और वो सेम साइज भी हो जाता है, करेक्ट? और जब now magnified virtual image also they are asking, so we know that magnified virtual image मतलब last case का मतलब क्या होता है, that the object is between pole and focus, then same size that we have discussed, that when the object is at C, correct? So object is at C, image would also be C and the size would also be the same. Now this was one way to deal with the question. Now the second way can be, what you can do, you read the question, you have all the four options in front of you, right? And you remember the cases. तो सेम साइज कब बनता है, जब ऑब्जेक्ट होता है एट सी. तो यहाँ पर से एट सी कौन सा दिख रहा है, दिस इज द फोकल लेंथ 10, तो सी मतलब ट्वाइस द फोकल लेंथ, सो सेम साइज दैट ऑफ द ऑब्जेक्ट, मतलब आंसर वुड बी एट 20 centimeter. And this you have to mention that when the object is at C, then only 20 centimeter. A magnified virtual, now you know that it is only formed when the object is kept between pole and focus. Focus 10 है, मतलब इससे कम होना चाहिए वो dimension, which is 8. So answer is 8. Right? Then magnified real image. So magnified image तो तभी बनता है जब object is close. So now we are left with 25 and 15. So out of this two, we'll select 15. And diminished image जब object दूर होता है, which is this one. So either of the ways you can proceed with the question, whatever clicks you in the examination. Okay, if you're very sure about all the ray diagrams and everything, then you can directly go from the options, but you have to write this thing. Okay, this was a very interesting question, right? Now we're moving to the next question. Question number 7. An object is placed at 15 centimeter. So what is given to us, that the object distance is 15. It is placed at 15, मतलब उसका distance है. Now with the sign convention, object distances are always negative. From a convex mirror of radius of curvature 60 centimeter. So radius of curvature is given to us as 60 centimeter. Now even when you keep putting this value for radius of curvature also, you have to keep it with sign convention. But for a convex mirror, we know that focal length is positive. The radius of curvature is also going to be positive. Now we have to find out the position of the image and its magnification. So position of the image मतलब image distance, and magnification we have to find. Position of the image and magnification. Right? So this is the question. This is the information that is given to us. Now we're going to proceed. Right? Now see, when we have radius of curvature, we have to calculate image distance. So we'll have to use mirror formula. Why? Because we have object distance. We have radius of curvature. So we'll use mirror formula. Mirror formula is 1 by f is equals to 1 by v plus 1 by vu. Now you have this object distance. You have to calculate v. But we don't know this focal length. So for that, we know that this radius of curvature is given to us and r is equals to 2f. So we'll get focal length r by 2. So 60 by 2, that is centimeter. So now we have focal length. We're just going to substitute it here. Focal length is positive in case of convex mirror. If it was concave, it is going to be negative. So 1 by 30 is equals to 1 by v plus 1 by U is minus 15. We're keeping it along the sign convention. Okay, so this was in denominator, minus sign, we'll bring it in numerator. So plus minus will become minus. So now we're left with 1 by 30 equals to 1 by V minus 1 by 15. See, now we need this V, so we'll have to send this 1 by 15 to the other side. If it was minus here, the other side will go and it will become positive 1 by 15, right? Now we have two fractions. So two fraction, we are going to calculate the LCM. So 30 and 15 ka LCM, if we'll take, it will come out to be 30. So all the LCM, and it is going to be 3 by 30. 3 by 30 is 1 by 10. Now 1 by 10 is equals to 1 by V, right? We need V. That means हमें reciprocal करना पड़ेगा. But we know that if we reciprocal, we can't do it only on one side. We have to do it on both the sides. So ये 1 by 10 will become 10 and this will become V. Again, this is a common mistake area. Because you know, in hurry, what we tend to do, हम सिर्फ 1 by V का V लिख देते हैं and the answer remains 1 by 10. So it's going to be absolutely wrong. Okay, so make sure that if you reciprocate one side, you have to reciprocate the other side as well. Fine. So did you got what we've done? We have to find out the image distance. We have object distance, radius of curvature. Somehow in the question, whenever you have radius of curvature, you always get a hint that if radius of curvature is given, we have to find focal length because r is equals to 2l. So focal length आ गया, u है, image distance के लिए will apply mirror formula. Substitute the value along with sign conventions. Take LCM, solve, reciprocate, answer is ready. Okay, so it's positive 10 centimeter. The position of the image is 10 centimeter. Now, we have to calculate magnification as well. Now, magnification is equals to minus V by U. Minus V का value कितना है? 10. The formula that we use is minus V by U. Minus of V, that is image distance. So, image distance is 10. U was already minus 15. Minus minus cancel, 10 by 15. So we're going to get it 0.67. I hope so this entire thing is clear with you. Position of the image and magnification. So see, magnification का formula सिर्फ एक ही पढ़ा है हमने. Magnification is equals to height of image upon height of object, which is equals to minus V by U. So depending upon whatever is given, information given in the question, you can apply the formula and solve it. Okay, and for image distance and object distance, either if magnification is given, then magnification is equals to minus V by U can apply, or if object distance and everything is given, then you can apply the mirror formula. Okay, so this was about this question. Moving on to the next question, question number 8. So we have to state two positions. Now again, it's a conceptual question in which the concave mirror produces magnified image. Now we need magnified image. So see, they have given the question that there are two positions in which you get magnified image of the given object, and you have to list down two differences between the two images formed in the two type of the position. So first of all, let's recall where are the two objects. So see, this was the first case when the object is between C and F. See, magnified image कब मिल सकता है? Only in that particular scenario when the object is very close to the mirror, right? Then only you'll get a magnified image, right? अब यहाँ पे कहाँ है? Between C and F. So see, following all the ray diagrams, the rules and everything that we have discussed, the image is formed here, which is magnified. The other case was when you're keeping or bringing the object between pole and focus. In this case, again, if we'll apply everything, we'll get an image which is magnified. So these are the two positions. So they have told us state the two positions. So what are the two positions? When the object is between C and F, or when the object is between pole and focus, we get a magnified image in both the cases. List two difference between two images. Now what is the difference that we can see? So see, in the first case, we have got an inverted image, whereas in the second case, we've got an erect image. So the first difference is the image formed here is real and inverted, whereas the image formed here is virtual and erect. They're asking us two difference. So the second difference is the image formed here is on the same side as that of the object. Can you see? Here is the object and here is the image. That is on the same side as that of the object. And the second one is image is formed behind the mirror. So these are the two differences. Real inverted, virtual erect. Same size that of the object, and it is behind it is from behind the mirror. Moving on to next question. A mirror is fitted in the wall of Agra Fort. When you stand at the proper location, A full-size image of Taj Mahal can be seen in this mirror. Right? So the question is clear. There is a mirror in the fort and you have to see the full-size image of Taj Mahal. Now, what kind of mirror is this? Right now, we have seen that. So there are two ways in which that question must have maybe asked in the exam. One that we've discussed in MCQ form, and this is a theoretical question. So which mirror? Right now we have discussed it is a convex mirror. Then the second part of the question was draw a ray diagram of such a mirror when the object is at infinity. So the mirror is a convex mirror. Now we are very sure about this. And the ray diagram for this mirror when the object is at infinity. So whenever you draw ray diagrams, there are certain things that you should be very careful about. First, draw the mirror correctly. It is a convex mirror. That means the bulged out portion has to be reflecting part and the others should be polished. Here naming is not given. You have to name the mirror. Then from infinity, parallel rays arrive at the mirror. So these are the parallel rays. As soon as they're going to touch the mirror, they'll be reflected. But you have to remember that convex is a diverging mirror. So when they reflect, they diverges out. So they are diverging. When you produce them backward, they meet at one point and they'll be meeting at focus. Why? Because they are parallel rays. So they meet at focus. So this is the ray diagram when the object is at infinity. Moving on to question number 10. Okay. For the given data, showing object distance and focal length of the three concave mirrors, answer the following. So there are three concave mirror, and for three concave mirror, we have different object distance and different focal length. The first one is, ये serial numbers मतलब this is first mirror, this is second mirror, this is third mirror. For the first mirror, the object was at 30 centimeter and the focal length was 20. Second, it was 10 centimeter, focal length 15. Third, 20 centimeters the object distance, focal length 10. Right? Now, out of the three, in which case the mirror will form the image having the same size as that of the object. Now, see, you have to study if in the exam a tabular form data is given to you. Study that nicely. Okay, so we have written it here. We've seen that there are three this thing. What is the heading? So this was the object distance, this was the focal length. Okay. Now, in which of this you'll get the same size as that of the object. So see, now you have to apply little concept. Same size का object कब मिलता है हमें? जब वो twice the focal length पे हो, मतलब वो जब center of curvature पे होगा, right? So now you have to study in the three cases. Focal length का क्या object distance twice है? No. Focal length का क्या object distance twice है? No. Focal length का क्या object distance twice है? Yes. So in the last case, the object distance was twice as that of the focal length. Focal length क्या था? 10. Object distance क्या था? 20. That means it is twice the focal length. So when the object is at 2f, then only same size image will be formed. That is the basic concept which is provided in serial number 3. The object distance is double that of focal length. So object is at 2f in the last case only, hence image will be formed of the same size in this case. Clear? So little concept and then again you come back to the tabular form. Same size कब होता है? ऐसे होता है. तो किस केस में ऐसा है कि twice the focal length है? Study all the three and then you'll reach to the conclusion. Okay. Similarly हम second part को अभी solve करेंगे. We'll think about this part. Which mirror is used as a makeup mirror? Now makeup mirror. So makeup mirror में when you have to see your face virtual only. You don't have to see your eyes upside down and your chin up. ऐसा नहीं देखना है हमें, right? Virtual image चाहिए. Case of concave mirror. We know that in concave mirror, virtual image is formed only in the last case, which is when the object is between pole and focus. Right? So अब हमें क्या देखना है? In which of this case is object focal length से भी कम पे रखा है. So here if you will see तो object focal length के बाहर है. Focal 20 था, object 30 पे है. Here also it is outside only. Focal length was 10, object is at 20. But in serial number 2, the focal length was 15 and the object is at 10. That means this is that particular case. Keeping your object between focus and pole. Keeping it there, then you will get a virtual, erect and a magnified image and hence our purpose of makeup mirror would be solved, right? So what is the answer? Mirror with serial number 2 is used as a makeup mirror, as in that case the object distance is less than that of the focal length. Hence the object is kept between pole and focus. So we get a magnified virtual image and hence the purpose would be solved. But that this particular question is very important. अभी makeup mirror के place पे they could have asked you shaving mirror also. It is again the same. They might have asked you dentist also. It would remain the same, right? So just remember it nicely. Moving on. The third part of the question was draw the ray diagram for part 1 and part 2. Part 1 मतलब क्या था हमारा? That when the object size is same as that of the image. So that means object is kept at C. So you have to draw the ray diagram. This was object, a ray parallel to principal axis after reflection passes through focus. Another ray passes through focus after reflection is parallel to principal axis. Both the reflected ray are meeting at a point at C only. So image is formed at C. Object is also at C. It's going to be of the same size also. And this is your concave mirror. Then the second case, the other case was when you use it as a makeup mirror. So makeup mirror matlab, that was case 6 that we have learned, when the object is placed between pole and focus. First thing is you are drawing the diagram for concave mirror here. So make sure that bulged in portion, cave wala portion, is your reflecting one and the other part is your polished surface. Same with this is your reflecting surface and the other part is the polished surface. Now keeping object between pole and focus. So this is your pole and this is your focus. Here we have the object. See, out of the 4 rules, you can use any of the rules. Here they are using this rule. We've learned differently, so you can do in that way also. Doesn't matter. Only thing is your answer should be correct. So what they've done, one ray they are passing it from center of curvature. It is reflecting along that direction. And then for another they are using angle of incidence is equals to angle of reflection. Again, this is the incident ray, this is the reflected ray. As you can see, they both are not meeting here, they're diverging from each other. In this particular case, what we have to do, we have to produce it backward. When we are producing it backward, we know that it has to be dashed lines and not straight line, because they are not meeting in real sense, they are virtual in nature. When you produce them backward, this is the image that you're going to get. Since it is above principal axis, it is going to be virtual and erect. Virtual because the light rays are not actually meeting. Erect because it is above the principal axis. Okay, I hope all the questions in today's class are very much clear to you. They are very important from the exam point of view. All are conceptual questions. So practice again nicely. Thank you very much.